So curve of best fit. Okay, so a curve of best fit. What we want to do is we want to do a scatter plot. We want to look at the scatter plot and say, hey, that looks like a straight line. So then I'm going to use a linear regression, a line of best fit, which is what we did yesterday. Or, I don't know, maybe that looks like a quadratic. So I'll try a quadratic regression and so on, right? We're going to try and say, well, what fits this data? And the idea is to model whatever fits this, right? So somewhere up here, I have this, the Yellowstone Grizzly Bear Investigation 2011. And I mean, I just thought I'd do this because the picture, whoops. I mean, the picture's kind of cute, right? There's the little bear up the tree. It's like fine, you can't see me. And what we're going to do is, okay, so what we're going to do is we're going to enter this data in. We're going to do the years. We'll call 1986 year 0. And what we'll be doing then is saying that our years will be years after 1986, right? So we're just going to go through, I'm just going to go through and number these. And that's what's going to go in L1. Okay, and then number of confirmed moth sites is going to go in L2. So L1, L2. So let's do that, and we don't want to see that. Okay, so we've got our numbers in L1, L2. We want to set an appropriate window for this. So we'll start with year 0, and we'll go to year 25. Now, if we want to do any extrapolation, right, where I go second calc and number 1 put in a value, then your window has to extend. So if I wanted to say, what's it going to be 30 years from 1986, then I'd have to make my x max up to 30, but we can adjust that later if we want. Okay, so right now we're just saying, all right, let's just close in on the data we've got. X scale of 1, let's go with 5s maybe. 1, they'd just be a little too close together, so it's just a little tough to find them. Y min, I think we could start at 0, and we can go up to 40, and we can do that by what? 5s, sure, why not? You could go by 4s, go by 5s. Okay. Let's go turn on the stat plot, right? Because we want to see the scatter plot. So we go second function, y equals. And I'm going to plot 1. Make sure that everything's off. At least 2, 3, and 4 are off. Okay, in case they were left over. Okay, turn on, plot 1. We want a scatter plot. That's this type. We want our x list is L1, our y list is L2. And we'll hit graph. And okay, so I can see, you know what, I probably made a mistake on this one, it looks like. So I'm going back into my data and checking like the 1, 2, 3, 4, fourth or fifth data point. Yeah, that's not a 1 down there, right? So 11, that's a 15. Okay, then it grabbed. Okay, so that looks a little better. All right, so you can kind of tell because you've entered the numbers. So one thing, on a quiz or a test, I'm not going to give you 25 numbers, Tanner. Actually 26, right? I'm not going to give you 26 numbers, Tanner. It'll probably be maybe up to 10. So anytime you enter, just go back, go through the list, check the X's, or check list 1, check list 2, make sure everything is good, okay? On the diploma, for sure, make sure that those lists are correct, okay? Especially if it's numerical response, right? Because if it's multiple choice and I put that in wrong, I'm likely going to get the wrong equation and I won't find it as one of the answers. If it's numeric response and they're asking for the value of C or something, then I'm going to get a value and it may not seem wrong, okay? All right, so what kind of shape is that? Is that linear? No, it's not really a straight line, right? It's quadratic. So here's the thing about quadratics, right? It could be, let me find the right thing to go to. Could be we're looking at, no, wait a sec, that's not what it looked like. Yeah, it is kind of what it looked like. Back there. Yeah, it could be we're looking at something that looks like this, but that's all we're looking at. Right? So we're looking at a portion of the curve. We don't know, right? But we can say, you know, yeah, if it did that, then it would be modeled by a quadratic, okay? So let's try a quadratic regression. So before we do that, there's one thing. Have you ever turned your diagnostics on, looking at the correlation coefficient? We're going to do that. So go, what I want is the catalog, right? So we're going to go second function and 0 to go into the catalog. Okay. We want to go to diagnostics on. The fast way to D is to hit this key here, because we're working with the green keys now, right? So if I hit this X-1 key, that'll take me down to the D's, and then I'm going to arrow down until I hit diagnostic on, and I'm going to hit enter, which is going to bring it into the display, and then I'm going to hit enter again, which is actually going to turn the diagnostics on. And what that does is it will give us what's called an R² value, which will kind of tell us how well the data points fit to what we're trying to do. Okay? So let's go to stat, over to calc. So let's say I'm going to try and fit this to a straight line, right? You don't have to do this, just watch. And I'm going to just try a linear regression. And I'm just going to hit enter. Okay? That gives me an R². So it says that, you know, 0.9 is reasonably high. Okay, let's try a quadratic regression. Again, I'm just going to hit enter, and don't do this yet. Okay, R², that's higher, right? 0.98, 0.99, right? So it's likely it's not likely linear. It's likely a quadratic. Okay, another thing we could try is, well, maybe this is part of, you know, a cubic. So this doesn't happen here, but it does this, right? It looks like a cubic graph. So let's try a cubic. So stat, calc, and we're going down to cubic. And hit enter. I've got to think for a while, right? It's 0.9, maybe it is cubic in fact, right? That's high R². But what we have to then do is apply some thinking to this, right? And say, well, there's really shouldn't be any, there's no data here, and it's probably not going to drop below 0, right? You can't have negative numbers of monocytes. So, you know, we got to make a judgment call at times, or be told what to do. So we're going to say this is quadratic. So I'm going to do quadreg, and I'm going to do the vars thing, and over to yvars, and hit enter twice. So what I'm saying to the calculator now is, okay, I've tried various ones, I've looked at the R² values, I think this is a quadratic. I want you to run the regression for me and to put the curve into y1. So I can do that. So it's going to give us, and you know, they're never going to be really great, nice numbers, right? Because these aren't made up numbers, they're actually observed numbers in the wild in Yellowstone Park. And we've got this, and we'll round to, let's say, maybe 4 decimal places because we're doing this. So y equals negative, of course things are going to disappear. Oh, don't want that yet. Y equals negative 0.0608 x squared plus 2.8374 x plus 3.5690 is what that's going to round to. Plus 3.5690. Okay, and that becomes our model. And back to the calculator then. Let's graph that. And we can see we've got a pretty decent fit there, right? That line is going nicely through those points. Okay, these guys a little high, this guy's a little bit low, but you know, and these guys kind of balance out on either side of the line. So we have a decent model for this. Okay, and now we can say stuff like, well, so where was that? I think that was here. Yeah. So now we can say stuff like, well, what's it going to be next year in 2012? So what year would I put in if I wanted to get 2012? 26. Okay, I want to put in a 26. So if I go second, calc, value, and put a 26 in, then it's going to blow up on me, right? Because 26 isn't in the window. I don't know why. The calculator should be smart enough to say, I'm going to extend this out, but it isn't. So we have to do it for it. So we're going to go to window. Okay, so I'm just going to hit quit here. we're going to go to the window, and we need to extend our x window out. So let's say I just go to 30 and hit graph. And now we can get the value. So second calc value, and we put in a 26. And we say, okay, we expect 36.23. According to this model, as a quadratic, things might start to drop off a bit. Okay, so we have to, use that as a limitation. We got to see, actually, as we go on in years, and that if we do see that they'll start to drop off, then we can be more committed. Yeah, I think this is quadratic because it's peaking, and now it's starting to drop off a little, right, over those years. So anytime you're running a regression, be aware of which regression fits. Will that continue? What assumptions do I make so that it continues? I'm assuming it's a quadratic, that it goes in this particular pattern. The other thing we can do is say, this actually has data for all the years, but if there was some data left out here, or we might want to say in what year were there 27? Was the number of moth sites 27? Then we go into y equals, we go to y2, because I want my y value to be 27. And we're saying, okay, that happens here. We do an intersect, second calc intersect. When I do that, I just want to move along this. And the intersection occurs at 10.7, so during year 11, okay, which is, and then we go back and we say 1986 plus 11 is 1997, right? So if we need to get a year out of an x value, we have to add the x value to 1986, because our x value is years since 1986. Okay, questions? Okay, so that's quadratic, right? So beware, it won't always be in a nice quadratic shape, right? So you won't always see, sometimes you'll see the data and it looks like this, and you can say, oh, obviously a quadratic, right? But sometimes it's just not in that particular shape. Okay, next one we've got is natural gas prices. And it's per 1,000 cubic feet. So that's it. And it's US average. So the data comes out of the United States, and it's dollars per 1,000 cubic feet, US average, and here are the numbers. So we'll go with year and price. So 1980, so the years are 1980 through 1990 inclusive. I'm going to have to squeeze the last two. Okay, and the gas prices are $3.06, so price in dollars. So dollars per 1,000 cubic feet, not square feet. You can't have square feet of gas. So $3.68, $4.29, $5.17, $6.06, $6.12, $6.12, $5.83. 554, 547, 564, and 577. Okay, what we're going to do for these is same deal, right? We're going to put them into our calculator. So I'm just going to bring the calculator back. And I'm going to go second mem number 4, clear all lists. So I'm going to clear my lists out. Go back to stat. I'm actually going to go to y equals, and I'm going to clear out what's in y equals too. Okay, so everything's cleared out now. We're going to go to stat, edit, and what are we going to put for 1980?
0.
0, right? Okay, so 0. in this case, the number is really the last digit of the year, right, in the 1980s, and then 10 would be 1990. And then we'll go over to L2. We'll put the prices in. 429, 517, 606, 612, 612, 583. Okay. We got numbers in? Not quite yet. We'll pause. Okay, so depending on our window, that can affect what we're looking at, right, and the shape of the curve. So let's try a fairly tight window. Let's try actually getting the window right. So L 3.6, not what I want 3.6. And I'm going to go to 6.15. So I'm going to stay really tight on there. And we'll go by ones, let's say. Okay, now our stat plot's turned on because it was turned on last time we just did a stat plot. So if I hit second graph, that's not what I want. I want graph. And we can see, man, it goes up, it comes down, and it looks like it's heading up again. It looks like a cubic, right? Okay, let's change the scale a little. Let's change the window a little, and let's just say that we do our y's from 0 to 10 and see what that looks like. And you notice it's a little less exaggerated there, right? It's starting to flatten out a bit. And if I did something like my y values from 0 to 50, right, which you wouldn't do, but it's almost like a straight line at this point, right? So you lose sort of an idea of the shape. Okay, so let's go back to, let's just do 0 to, let's say, 7. So, not linear, right? It's not a straight line. Not quadratic, because quadratic, this would have to keep coming down. It's starting to climb back up again, right? So then we're thinking, all right, looks like a cubic. So we're going to go to Stat, Calc. We're going to go down to number 6, a cubic regression. We're going to hit Enter. We want to put the regression equation into y1, so we're going vars over to y vars. Hit Enter twice. So we're telling, now remember, whenever we don't put lists in, when we run a regression, if I don't say L1, L2, or L3, L4, whatever, it will assume L1, comma, L2. Okay, and we can hit Enter. And there's the equation. We got a fairly high R squared value telling us that it's a pretty decent fit to that. Okay, and we can write out the equation. 0.0124. Y equals 0.0124 x cubed minus 2.421 x squared plus 1.4070 x plus 3.4445. Okay. So that's our equation, right? Now, if I want to check values, I want to say, well, what's the price going to be? And again, we're making assumptions here, right? Anytime that we're doing a model, we're going to assume the data is going to continue in that pattern. Okay? We do know that gas prices do tend to kind of rise and fall, right? So, I mean, right now they're in kind of a falling mode. So we'd want to collect more data and just look over a longer period of time, right? And, you know, maybe over a certain period of time they were basically flat. It was just always the same price pretty much. And then over other times it changed. Okay, so if I want to go to, say, 1995, what year would that be? like year 15, right? So I'm going to extend this. I need to extend my x max out. And let's kind of see what happens. Now it's fitting the graph, right? We say, oh, wow, things are taking off here. So I need to change my y window as well. Y max, let's say 15. Okay? Now, this model's likely not to continue like that, right? It's likely not going to, it fits this limited set of data, very nice, cubic fits quite nicely, but probably it's not going to, shoot up like that and continue, because this will continue up forever, right? And we know that that's not what happened with gas prices, right? Nor is it likely to. There has to be a certain limit. But using this model, if I wanted to calculate value for 1995, so I'm going to use, what, 15? Then it'd be $12 per 1,000 cubic feet, right? If we want to check, based on this data, how the model's performing, we could go look up the data for 1995, right? Or if we put more data into our table, we would get a more accurate function to fit it, okay? Which might just flatten these out a little bit more. So maybe it goes along like this, but it's climbing a little bit gentler, but still is cubic, right? It still has rise and fall. Okay, questions? So I want you to use your textbooks as well, right? So look through the textbook stuff on this, look through the examples, look through the... This is our last section, right? So tomorrow it's review, and then Tuesday is the test. This is our last section, so tomorrow's review. So if you look at modeling data with a curve of best fit, which is on page 307.
Excuse this interruption. If the following students can please make their way through the lines, commas, conference room.